Hey serverless friends, welcome to another Azure Functions University lesson. And this time we're going to talk about deploying .NET 6 function apps. So before we dive into the lesson, let me quickly remind you that we have lots of content on GitHub. This is the link. If you go to bit.ly/az-func-uni, you'll end up at this repo. And as you can see, we have quite a big list of lessons across different languages and across a lot of different topics. If you want to contribute, that will be very welcome. We still want to write a lot of lessons in a lot of different languages, so we can definitely use your help here. We have a contribution guide, so please have a look into that. There's also quite a large list already of existing content requests if you look at the issue list. So feel free to pick one of these issues up and contact me if you want to help. All right, let's move on to the lesson of today, the deployment lesson. So we're going to deploy our function apps to Azure, and we're going to focus on .NET 6 function apps. So if you have seen the .NET Core version of this lesson, it was about .NET Core 3.1 function apps, not much has changed. So only some version numbers have incremented here and there, but there's not so much different. But if you're completely new to .NET 6 deployments and function apps, then definitely stick around and I'll show various ways how you can do it. So what we'll cover today is first some prerequisites, then understanding the Azure resources. Then the first deployment option is using VSCode. Then the second one is to use the Azure CLI. Then we're going to do the deployment of the function through the Azure Functions CLI. And finally, we'll do a deployment using GitHub Actions. So these are not the only ways to deploy. There's even more ways you can do, but these are the options that will be covered in this lesson. So let's start now with the prerequisites. So this is actually the only lesson where you actually need an Azure subscription, because all of the other lessons should work always out of the box, and you can completely run them locally. But for this, you definitely need an Azure subscription. What you also need is a local folder with a function app, and there is a template repository that you can use. I'll be using VS Code with the Azure Functions extension to deploy the function app. And for the final example where we are touching GitHub Actions for the deployment, you'll actually need a GitHub repository with a function app project. But again, I have a template for that, which you can easily use. And that is this template project. So there's another repository called function app-deployment-.NET 6. You can use that. You can use this template to create a new repository, and you get the complete content of this repository, and you can use it all through this lesson. Okay, so let's start with understanding the Azure resources, because we are talking about function apps, and when you run locally, you have your function app running locally, but when you have it running in the cloud, that is something different, and there's more than just the function app. So the function app is the most inner box here, but the function app is actually running inside an app service plan. And the app service plan, that is a definition of some virtual machines with a certain size. And if you're on the consumption plan, then you don't have any control over the size of the machine. But if you go one tier higher, you go for premium plan, then you can actually define or select different machine sizes. So if you need more CPU or if you need more RAM, you have a bit more control over the app service plan part of it. So that's the compute part, but Azure Functions also need a storage part, and that's the storage account. So that's an Azure storage account, and you will use some storage there, because when your function app is completely scaled down, so no one is using your function app, then this part is not used. So this part is completely then decommissioned. But your files that are required to execute your code, they still need to be stored in the cloud somewhere, and they need to be quickly copied to this function app part whenever a new request comes in. And the files are stored in your storage account. And finally, we have the most outer part in this diagram, and that's the resource group. So it's a common practice for let's say every new project to create a dedicated resource group for those projects, and all services that belong together, you can put that in a resource group. So those are all individual Azure resources, cloud resources that we will need to provision, and we're going to provision that using different methods in this lesson. Okay, so let's move over to the first part, and that's deployment using VS Code. So I'm going to move my window here a bit. So I have a VS Code here on the right, and I have opened the function app deployment.net 6 folder. So I've cloned this solution project locally, and I've opened that in VS Code. So if you have opened this folder, then VS Code has recommended some extensions for you to install, and one of the extensions is the Azure Functions extension. And if you did install that, and I hope you do because you need it, then you will have this icon here, the Azure icon, and if you click on that, like I did here, you would see this Functions tab. And I have a couple of different services because I have other extensions installed. But this one is the one that you need. So it recognized that we have a local project running, but it also has detected that I have 2 different Azure subscriptions, and we can even browse here to those function apps which are already deployed to the cloud. But this is not an intro in how to use this extension. We are going to use this extension now to deploy our local project to the cloud, and also provision all the required cloud resources. So how are we going to do that? Well, there's this button here that has looks like a cloud and has an up arrow in it. And if you hover over it, you would see deploy to function app. It's very tiny here on screen, but if you're running it locally, you should see that. So if you have selected your local project, click on this deploy to function app button, and that will pop up this command prompt. And here you can select your subscription. I have 2 subscriptions, so I need to select one. If you have one, then you probably don't need to do anything here. So I'm choosing my sponsorship subscription. In this case, I have already deployed this function app, but I'm going to deploy it in another function app so we can see what are the steps that are involved in deploying this. So I'm choosing this one, create new function app in Azure. There's also an advanced way to do it, but let's keep it simple first, and let's create this one. So it's asking now for a globally unique name for the new function app. So let's use something here that we have mentioned in the lesson, but I'm going to make it a bit different because this already exists, because I did an earlier deployment. So let me see if this exists. No, this doesn't exist. So this will be my my name for my function app. Then we press enter to confirm, and we are now in step 1 of 3. So let's continue. We have to select the runtime stack. Well, it correctly suggested that we are in the .NET 6 runtime stack, so that's true. And we are also using Azure Functions version 4, since that's the only one which we can use for .NET 6, so that's correct. We can then select a location in the cloud for our resources. So always choose a location that is close to your users or close to yourself if it's just for your demo. So my closest region is West Europe, so I'm going to select that one. So now we see at the bottom here that it's creating all kinds of resources. Now it's creating a service plan, now it's creating a storage account, and we see some generated names for the service plan and the storage account here. So we can see it's doing some stuff. Step 4 of 6. So it's running. So that's good. And quickly we will we can check if it's successful. So we can check the creation. We can check it both in this extension, so the functions extension in VSCode. You can also have a look in the Azure portal itself. So now it's creating yet another resource, the application insights. It's also creating, so that's very nice. And finally, it creates the function app itself. So it's step 6 of 6. So now it's nearly done. So let's see if things are already showing up here. No, not yet. We can see that it's still in creation mode, but it's nice that we can also see it here in this drop-down list. I did not know that. So that's good to see. So now it is done. So now it's running a pre-deployed task. So what it's done now is it created all the cloud resources, but now it is actually publishing the local function that we've that was present here in this repo. And now it's trying to push it to the cloud, but something is wrong. We get this message. The remote runtime.net for function app. I've made a mistake in the selection. So I've selected .NET, but not .NET isolated. So that's a good point. Let's try this again then. And let's see how far we get, because I've chosen the wrong type of remote runtime, because now with .NET 6, you can either run it in isolation mode or not, and I've selected the wrong one. So let's do this again. A new function app. So let's see, because VSCode, because now it already exists. Let me just create a new one, VSCode 2. So we are in v4. That is .NET 6. Yeah, but there was not even an option to change in .NET isolated. That is interesting. So what happened here? Let's have a look. So this is the one we deployed, but it did got an error message. So let's have a look at the application settings here, what it says. Click, yes, I want to see it. So it says functions worker runtime.net, and that probably should say functions worker runtime.net isolated. So I'm not sure why the installation wizard did not pick that up, because that is definitely defined right here in my CS project file of the function. No, sorry, in the local settings host. So my local function is a .NET isolated one, but I'm now trying to create one which is not isolated. Okay, let's see if we can fix it by, again, going to this functions worker runtime. And can we change this setting here? Let's try this. Okay, so now it's updating the value. So now it says .NET isolated. And the only thing what maybe did not went through correctly is the deployment of the function. Let me actually check if that's there. So there should be an HTTP trigger function in there. Takes a bit of time to read it. You can also look it up in the portal though. So here on the left is the Azure portal. Let's refresh this, because this should now show our new function apps as well. Yes, here it is. So this encountered an error, bad gateway. So this doesn't look good. But here, this shows okay. And if we do the same thing here, we see it's recognized now as a .NET 5 function app. Yeah, so there's definitely something wrong with the configuration now. So it's using function extension 4, which is good. .NET isolated, that's also good. And this is all looking fine. But our functions not. I'm not sure why it mentions .NET 5 function apps here, because that is not mentioned anywhere. So that's interesting. I'm restarting it from the VSCode extension. I could also restart it here. It doesn't matter much. But let's see if the function is now recognized. And if not, I can try to deploy it once again. So it's not listing any function at the moment. So maybe that's the issue indeed. All right. So what we can do now is deploy it once again on top of the existing function. So we choose my sponsorship. We choose the existing resource, the cloud resource that we just created. And now it's asking, are you sure you want to deploy to this resource? And I say, yes, just go ahead. So now it's running the same tasks again. And let's see if it works now. So it's deploying. Very curious if this will work. So just before I tried the CLI deployment and also the GitHub Action deployment, but I didn't try this extension deployment. So that's a good lesson for next time. Look, deployment completed. All right. So fixing the setting to .NET isolated manually, that did fix the issue. So what I did was I went to application settings and I went to the functions worker runtime variable, and that was set to .NET, but I now changed it to .NET isolated. And then I did a redeploy of the same thing, but selected the existing cloud resource. And now the function should be there. Yeah, our hello world trigger is there now. All right, so that worked. Yeah, so I'll check offline if there's something wrong in this deployment deployment template that is provided by the Azure Functions extension. Maybe my version is not up to date. That's also possible. But at least it's working, so that's good news. All right. So we did that. We got the green light that the function is actually deployed. So that's good. So that's the first option. And to be honest, that should be the easiest option in this case. It wasn't the easiest option because it went wrong with the .NET 6 isolated mode. But normally this would be the easiest way to do it. But there are other ways how you can deploy your function apps. So another really convenient way, I think, is to use the Azure CLI. So because using this extension, and this extension is under the hood also using the Azure CLI. So this extension abstracts some stuff away from you, right? So we went through this deployment mode, and we choose, let's say, a relatively simple deployment. That was also an advanced option. And using the simple mode, we only have to specify a function app name. And we didn't need to specify a storage account name or an app service name or stuff like that, because all of these things were generated and some kind of templated names were used. So if we have, because now we are in the Azure portal, and if we look at the created resources, so this is the function app that was created by the extension, and we see the resource group. So that's called AFU deployment.net 6 VSCode F. So it was some kind of a concatenated name that has now been auto-generated for the resource group. And if we look at that resource group, then we see the rest of the cloud resources that have been created now via this VSCode route. So this is the name of the storage account. That's also created for us. The name of the app service plan was created for us. And in addition, we have an application insight resource as well. So that's very useful if you want to do some logging and metrics. And then it's very important to have an application insight resource as well. So you only have control over the name of your application. If you do it via the advanced mode, the advanced deployment mode, then you can also specify the names for the storage accounts and for the app service plan as well. But now let's have a look at deploying and provisioning using the CLI. So this is done in 2 steps. So first, we're going to focus on creating the Azure resources using the Azure CLI. So that means we'll be creating a resource group, we'll be creating an app service plan, a storage account, and a function app. But that does not include the deployment of our packaged source code to this function app. So that's purely about the infrastructure, our cloud infrastructure that we are creating. So we're going to use the Azure CLI for that. So that's actually also one of the prerequisites which I didn't mention yet. So I'm going to make this a bit bigger. We are not going to use the extension anymore. So I'll also collapse this so we have a bit more space. So what we can type now is we can type AZ in a terminal, and that will hopefully, if everything is installed correctly, you would see this. Some nice ASCII art. Always a fan of that. And the Azure CLI can be used to manage all kinds of Azure resources. It's really a very useful tool. You can do really a lot with it. So we'll just be scratching the surface for this function app stuff. Before you can use it, you need to use AZ login, and that will then you can then authenticate. You need to log in then into your Azure account using a web browser. I already did that, but if you haven't done so, just type AZ login and follow the instructions there. If you have multiple accounts and multiple subscriptions, then you might need to set your account. So for instance, AZ account help. So AZ account lists. So I, for instance, have two different accounts, and one is my default. So that is not this one. Yeah, so this is currently my default one. So my Microsoft has a sponsorship, but if I don't want to use it, I have to use a different account. So you can use that by typing AZ account set -s and then the ID of your subscription that you want to use as a default in this session. But for now, my default is correct, so I'm good to go. So the first thing that we are going to create is the resource group, because everything we create afterwards, we want to put that in our resource group because it's a convenient way of managing and grouping all our cloud resources. So I'm using PowerShell here. You can also use another shell, but I'm using Windows machine, and I'm a bit familiar with PowerShell. So I already have these variables. So I have some variables because I'm reusing some of that. So whenever you create a resource, you always have to specify the location, for instance. So I have a location variable, and that contains West Europe. So I don't have to type West Europe everywhere, but you can just refer to this location variable. The same is true for the region resource group name, RG name. So that is set to AFU deployment CLI RG. And what else do we have prepared? I think I also have a function name already prepared as well. Yes. I already have some names put in variables so I can easily reuse them. So in order to create a resource group, we use this command, az group create, and then we need to specify several variables. We need to specify a resource group name. We need to specify a location, and there's an optional tags. But I'm using these tags in order to do some cleanup afterwards. So I'm specifying some tags. When I paste this into the terminal in VSCode, it asks me to, okay, are you sure you want to paste 4 lines of code in this terminal? But yes, I'm okay with that. So it executed. And we see where we have an ID here. So that means that the resource group is now there. We can see provisioning state is succeeded. So our resource group is now available in Azure. So it's good. So the next thing we can create now is the storage account. And I did mention that, but also I have the storage account name also in a variable. So it's st name. Yes. So this is my storage account name. So the next account that the next command that we're going to execute is az storage account create, and that will require a bit more parameters. So the first one is the name of the storage account. The second one is the name of the resource group. Then we have to specify the location, then a SKU, so a certain tier. You're going to do this standard LRS. Then there's a storage type kind. So we're going to do storage v2, which is the newer type of storage account. And we specify an access tier. Okay, so access tier hot. So it's in, and let's VSCode asks me again. All right, so now our storage account will be created for us. You see it's running, so that's cool. Naming of storage accounts can be a bit tricky because there are a lot of restrictions on the length and the characters that you can use for the storage account name. So Azure is not very flexible in that. There is actually a command you can use to check if the name you have in mind, if that will work. So you can type az storage account check name and then provide a name, and that will give a indication if the name is suitable to be used for your storage account. So storage account has been provisioned, so that's there. So that's great. So now we have a resource group. We have our storage account. So the next thing what we need to create is our function app. The thing we didn't do separately is the app service plan. But using this az function app create command will take care of both the app service plan and our function app. So I'm going to copy this, and I'm going to replace one thing, and that is the function app name, because I have that in a variable. A name. So the az function app create requires also some parameters. So we specify the name of the function app, we specify the resource group, we specify, in case we want to use consumption plan, we specify the consumption plan location. We specify the storage account name. We specify the runtime. So this it's .NET-isolated. And we specify the OS type. In this time it's Windows, and we specify the functions version, and that is 4. So let's run it. So running this command will create both the app service plan, and the function app for us. All right, so let's wait a bit until that is done. So afterwards, we will use the portal to see if that has been created. So here we see it also created an application insight resource as well. So that's great. And yeah, this is the feedback that it has all been created for us. All right. So I think this one, let's check the storage account name. The group name. Yeah. AFU deployment CLI RG. Yeah, so this is the one that's now been created. And we see that we indeed have an application inside, we have a function app in here, and we have a storage account in here. So that's looking good. Okay, .NET isolated not found. That's probably because we don't have any functions still deployed to it. So I guess as soon as we deploy our function into this empty function app, then this will probably be fine. All right. Let's go then to the next step, because now we only provision the cloud resources, but we still need to deploy our function code itself. So there's another CLI we can use for that, and that's the Azure Functions CLI. So that is the same function CLI you can also use when you're doing local development. And we can also use that to deploy our function to Azure. So if you type func into your terminal, then you should see something like this. So you know it's installed. You can check the version. It's version 4.0 something. So that matches with what you want to do. It's important to realize that when you run the Func CLI, you should be in the same folder as your Azure Function project is. And right now I am in the root folder. I am not yet in my azfuncuni.hcp folder. So I should go one folder deeper. This is the folder where my file is. So this should now work. So the command to publish our function to the cloud is func Azure function app publish, and then the name of our function app. So that will be the minimum. You can do some optional part as well. Let me first copy this and put it in here. The final part, publish local settings -i, means also go through your local settings, and in case there are settings there which are not in the cloud yet, copy those settings over and do it interactively. So that's what the -i means. And if you have local settings that exist both locally and in the cloud, you'll see a prompt where it will ask, okay, yeah, we found this setting, but it also exists in Azure. Do you want to overwrite it? So this is not needed, but I just want to make sure that it's there, because quite often you have some local settings in your local settings JSON file, but you might not know how to get it uploaded to the cloud. So this is one way how to do it. So let's change the function app name. This FA name. All right, so now it will build our function app, and it will publish it to Azure, so we can follow what it's doing. So it's restoring our project. It has built our project. So now it's getting the information where to publish it. So it's created a zip. Now it's uploading it. It's already done. Okay, it's setting the function worker runtime. And this is what I'm talking about. So now it's asking me there is an app setting Azure Web App Storage, and that exists in both Azure, but it also exists in our local settings JSON, but the values are different. So do we want to override the value in Azure with the value we have in our local file? And I'll show you what's there locally. And there it says use development storage is true. So this is purely a development setting. So that's definitely not something we want to have available in Azure, because in Azure it's pointing to the created storage account. So in this case, no, we do not want to override this. All right, so it's done. Final part, syncing triggers, and then it should be there. Yes, so here we have our hello world trigger. Excellent. So let's see if we refresh this, if the function app here is also happy. Yes, so there are no more errors because it's not an empty function app anymore. There is an actual function in there. Let me quickly prove it to you to go to the function. Yes, so here's our hello world HTTP trigger. Again, it complains about editing.NET 5 function apps. I think this is just an old setting. It's not that, I think, aware yet of the difference between .NET 6 functions and so on. So I don't think this is something to worry about, because our configuration should actually mention the right settings. So it's probably all good. Yeah. All right. So this has all worked. Functions are there. The next thing we can do now is moving to GitHub Actions. So for this part, it's important that you have and not only your local folder with your function app, but you actually need to have a GitHub repository with the preferably with this template repo. So if you have created the GitHub repo based on this template, then you're good, because that contains all of the files that I'm going to talk about now. All right, so if you have ever used GitHub Workflows or GitHub Actions, fine, that's great. If not, maybe a very, very short intro. So GitHub Workflows and Actions are a way to do continuous integration and continuous deployment on GitHub. And it uses YAML files located in a .github folder. So we can see that right here. There's a .github folder and there's a workflows folder. And there are a couple of YAML files in there. And it's a super flexible way to do anything, to automate anything in GitHub, or to deploy cloud resources and to build and test your solutions. You can do anything with it. There are literally thousands of GitHub Actions out there in the marketplace. You can also create your own GitHub Actions, which is also quite fun to do. But here we are specifically looking into how can we deploy our function apps using specific GitHub Actions to Azure. Before we are doing that, we have to give GitHub, we have to authorize GitHub to do that, right? Because when we do stuff from our local machine, we also have to log into Azure. For instance, what was needed for the CLI, and also when you use the Azure Functions extension, then you also need to sign into Azure before you can actually do some deployment with the extension. So you always need to sign into Azure. But now using GitHub Actions, that process is a bit different. You need to create a service principal. So you need to create something in Azure, an account in Azure, and that account will be used by GitHub in order to create your Azure resources. So that's this step one. So you need to locally use the Azure CLI to run AZ, AD, SP, create for RBAC, and then provide a name, and the name can be anything. Role should be contributor. Then you should provide a scope for this role, and you end with the SDK auth. So this will generate a service principal in Azure AD with the role of contributor and for this certain scope. And the scope here is quite wide because the scope is the entire subscription. So when you're doing production work, you should probably not do this. You should probably provide a narrower scope. So maybe you should scope only within a certain resource group. But in this case, I'm also creating the resource group. So in this case, I really need the wider scope of the entire subscription. So I've already done this, but you can follow these instructions and you will have a valid service principal that you can use. If you run this, you get back a JSON output that looks like this. You have a client ID with a GUID, client secret, subscription ID, tenant, and then you have a couple of more fields. You should copy that entire block of JSON output, and you should put that in the GitHub repo settings where you are building your GitHub action. So in this case, this is my GitHub repo that contains the actions. You should go to settings, and then you should go to secrets and then actions, and you should create a new repository secret here. And then you can give a name for the secret. That can be anything. And here you should paste in the JSON output that you got for the service principal. So since I've already done it, the value is here. So this is the name of the secret I created. Once it's created, you can't see the value anymore. And you can update the value with something new, but you cannot see the value anymore. All right. Yes, let's get back to this now. Where are we? So at this point, you have a GitHub secret that contains the service principal JSON output. So GitHub is authorized to do deployments for you. And next we can have a look at the structure of the .github /workflows folder and the different YAML files in there. So in the template repository, there are a couple of YAML files. There are currently 3 in the workflows folder. You don't need to bother with the link checker. That's just a task that will run periodically to check markdown files if the link still works. So it's not really relevant to this lesson, but the other 2 are very relevant for this lesson. So there's an application YAML and an infrastructure level YAML. So let's start with the infrastructure one. So if you are not familiar with GitHub workflows or actions, I will briefly go through the schema. So you can supply a name for your GitHub workflow. In this case, we named it infrastructure. You can then define how this workflow can be triggered. So in this case, it is triggered when you push to main, but only when this exact file has been changed. So on any other changes in the repo, this will not trigger, but only when this file is changed. The workflow dispatch is another trigger, and it means I can start the workflow directly from the GitHub UI. Usually that's not needed, but in case something doesn't work and you want to manually trigger something, it's useful to have. Then there's a section that defines some environment variables. So we've defined an application name, we've defined the location, resource group name, and storage account name. And we'll be using these environment variables later in this YAML. So then we have the jobs section, and again, you can give your own name to this job. You have to specify on what type of runner will be used. On this case, we're using the latest version of Ubuntu for the runner that executes all these jobs. You've also specified an environment. An environment that's again a GitHub specific concept. Let me briefly go to this repo again. So that's again tied to the repo that you're using and where you're running the actions in. So again, if you go to settings, and there should be a tab called environments. So in this case, I have defined a production environment. This is not a mandatory thing, but it can help you organize your environments a bit better, especially if you have multiple environments like develop, test, acceptance, production. Then it can be useful. But also if you have a bit of stricter rules on when or how you should deploy to production, it can be useful to have an environment. An environment, in this case, you can have protection rules. So if we click on this, we can see protection rules. So when it has protection rules, it means that you can only deploy, you can only go and use this environment if some things are taken into account. And here, since the required reviewers is ticked, it means that one of the contributors of the repository needs to give a manual approval if the deployment is allowed. You can also introduce a wait timer to wait before deployment is there. And that's not ticked at the moment. And the other one is you can actually select from which branches you allow a deployment to this environment. So in this case, I only allow source code from the main branch to be deployed to production. You can even have environment-specific secrets. So in this case, the settings are not so complex, and we just need a manual approval before we can actually deploy to production, and it only allows stuff from main to go into production. But again, the whole concept of environments is optional. You can also leave this out completely and do not worry about it. But it's definitely nice that it's now offered. Then a job contains an array of steps. And the first step is usually that you want to check out this repository on the machine that is running all of these steps. So there's a checkout step, this one. Then we are going to log into Azure, and here we are using our Azure RBAC credentials secret. So have you use this syntax secrets.azure RBAC credentials. So this is the name of your GitHub secret that contains the JSON output for the service principal. So once you've done this, and the other actions that actually use Azure are allowed to do that. So the next step is create a resource group, and we're using the Azure CLI for that. So I think this is pretty nice because the Azure CLI, you can use it locally, but you can also use the same CLI with exactly the same usage and the same arguments. You can use it as well in your CI/CD pipeline. So if you learn Azure CLI, you can apply it in different places, and I think that's a nice concept. So we're using the Azure CLI GitHub action, and that allows you to execute an inline script. And this inline script should be familiar because we have been running this before as well in our own terminal. So it's using AZ group create, and we provide a name that's read from environment variable, provide a location that's read from an environment variable, and we're also specifying some one tag, which is again optional. So once the resource group is there, we create our next resource, and that's the storage account. And again, we use the Azure CLI GitHub task for it, where we execute a script, which again is the same script as we used locally. Finally, we use again a Azure CLI task, and then we create the function app and also the app service plan. So that's the infrastructure part. So if you have this defined like this, so this will create your resource group, your storage account, and your function app and your app service plan. And you're authenticating using a service principal, and that is stored in a GitHub secret. So that's very safe. So there are no secrets in your source code whatsoever. And this process is repeatable and reliable. So it's one step better than executing this CLI steps manually from your own terminal, because what happens when you're not there, or if your colleague execute this, will they use all the same steps? At least all of the steps are defined now and will always be the same. So that's the cloud infrastructure part, but now we still have to deploy our application code, and that can be done in this application YAML. So the same part, we have given it a name. Also, this is executed when we push to main. We have slightly different requirements on when we want this to be triggered. So in this case, we are monitoring the paths of the Azure Function app. So if any code in the Function app changes, or if this application YAML changes, then we want this application workflow to execute. If you, for instance, just change the README file, this will not be triggered, and this should be fine, because changing a README should not affect the Function app. Again, we have some environment variables. So again, we're using the name. You specify the application package path. So that's the subfolder where our source code is. We have a variable for our resource group, and we specify the .NET version, because we'll be building our application in this step. So if you look at the job and the steps, again, we'll be doing a checkout first. Again, we will be doing a login with the for the Azure in the Azure CLI, and using the same secret, the Azure RBAC credentials. Then we'll be selecting which .NET version we are using. So we use an action called setup.net for that, and there we specify the .NET version we're using. Then we are building our project. So that's done via a shell action. So we run .NET build, specify a release configuration, and specify an output folder. Then the next one is an Azure Functions specific action. So here we use the Functions action, and we provide an application name, and we provide the location of the output, where the package is. And this step will do the deployment of the Function app code. So once this is done, and then you have your functions available in your Function app. This final one, that's an optional one, and then you only need it when you need to set some application settings in your Function app. And it's very likely that you will need to do that, because just this one, just using the Azure Functions action, that will do nothing with your application settings. So you will need a way to actually set your application settings. And we've seen in the previous exercise, locally we can use the Azure Functions CLI for that, to push our local application settings to the cloud. But if you do it via GitHub Actions, we have to use the Azure CLI for that. So we use the Azure CLI with this script, AC function app config, app settings set, and we have to provide the name of our function app, the resource group of the function app, and finally we specify the settings variable, and there you can have several lines with different settings you want to set. So in this case, these settings are completely hard-coded in the workflow, but it's more likely that you'll either have settings that you read from environment variables, or you have some settings that are in GitHub secrets, for instance. All right, so how does this look like in GitHub? So let's briefly go back to this function app deployment repository. So if you go to the Actions tab, there we can see the different workflows we have. So for instance, this is the infrastructure one. So there have been some executions lately, but if you click on one of those things, we can actually drill down and see what it has done. So here we can see the individual steps that it has executed. The same is true for the application one. Here we see a list of the executed application. And oh, this is interesting because the last three I have approved to be deployed to production, but some early ones I did not approve. So here we can actually see that I have actually requested my review to deploy to production. So this is now ready to be, my application is ready to be deployed to the production environment, but it's still waiting for an approval. So if I click this and do approve and deploy, then it will start the deployment to Azure. I'm not doing this now because I've already run later changes. So I already have some running function app in the cloud now. All right. So that was quite a bit of information. We're almost at the hour mark now. It's quite some different ways to get your function apps to the cloud. I think it's very nice that you can definitely do it straight from VSCode. So if you're just doing a one-off proof of concept, you can do it very quickly and easily. If the right .NET version and isolated version is working. But otherwise, I would say, yeah, definitely get used to the Azure CLI. It's very convenient to use because you can use it and locally, but also in the cloud, in your CI/CD pipelines. But again, this is not the only way, right? There, you can also still use ARM templates. You can use Bicep. You can use Terraform. There are a lot of different ways how you can provision your cloud infrastructure. So, and there are definitely more ways. And I'll definitely make in version 2 an advanced lesson of doing deployments in some time. Regarding the homework, if you have your own solution, so not this templated one, but if you have your own .NET 6 solution you want to try out, please try that as your homework. If you have any questions, you know where to find me. Reach out on Twitter at Mark Duiker. Last but not least, if you want to contribute to a lesson, you're more than welcome. Also, reach out either via Twitter or create a content request issue on the GitHub repo. And again, I'll give you the link here. So this is the link to our repo. And yeah, if you are happy with this content, if you like it, please subscribe and on YouTube, and also like our videos. That will only help us spread the word. So tell all your friends and family about Azure Functions University. Thanks, everyone. Until next time.